Hello friends, today in this video we'll be discussing an easy problem from LeetCode. The title for the problem is range sum query. Now let's understand the problem statement of the question given over here. So the problem statement states that you have been given an array of nums that contains some integers and you have to calculate the sum of elements from the nums array between left to right. Now left and right would be given to you for each query and there can be multiple queries and your sum should include both left and right. Left can be greater than or equal to right. Left can be lesser than or equal to right. Now you have to implement a class where you have to implement one function which is sum range, where you will expect two parameters, that is left and right, and you have to calculate the sum accordingly. The constraint given to you over here is stating that the nums array length can be from 1 to 10 to the power 4. That means you can have maximum 10,000 elements in that array. And the second important constraint that is given to you is that you will have at most 10 to the power 4 calls made to the sum range function. That means you can have 10,000 calls made to the function. So you have to optimize your solution so that these calls collectively don't take so much of time for the client. So let's understand this with some example and then develop an intuition to lead to a better approach or better solution. So now let's take an example and understand precisely what this problem statement is asking us to do. So let's say I have an integer array, nums to be specific, containing few elements, let's say 5 element, 1, 2, 3, 4 and 5. Now when your sum range is called, let's say your sum range will be called for 5 times and each time we have few instances for left and right, let's say 0, 2, then 1, 2, 1, 4, 3 and 4. Then can be 0, 4. Now 0, 4 is practically the complete array's sum. But now let's understand how you would normally do. So first let's discuss the brute force approach and then try to solve it. Okay. So whenever your query is submitted, so that means you have got the left and right index. The first approach that came to my mind at least is that I'll traverse the array, start traversing from the index, left index till the right index. That means my loop, for loop, would start its value from the left and go up to right, and this is both including, so these two would be included, and I'll keep adding my answer sum plus is equal to nums of I, and I'll return the sum. Now let's say you have only 5 queries, it's okay, and your integer, so the length is also 5, that is very small, so it is okay to do this. Now what happens if you have a nums which contains 1000 elements or let's say 5000 elements, and you have these queries stating that calculate the sum from 0 to 999. So that would be a sum of 1000 elements. That means 1000 times you will be iterating. Now let's say your second query is stating that calculate the sum from second to 990. Now if you practically look at this second query, the second query you would have calculated when you were doing the first query, right? So that means if you are calculating the same set of indexes again, it is waste of your CPU, right? You don't want to waste your efforts or your CPU efforts over here to calculate the same thing. Just only thing that you have to remove is the value ranging from 0 and 1 and from the right side value from 991 to 999. You just have to remove these two elements from this answer, and that's it. But what happens if your query states that you have to calculate from 0 to, let's say, 1001? Now this would mean that you have to add some value in this answer. So if you develop an approach which utilizes this logic, where it says that you can have a query where you might have calculated some part of it, and now you just have to either subtract or add few new elements that are required, and you keep building that logic. Okay, so how can you come to that approach? So let's discuss a optimized approach. So let me take this fresh, and let's say I have this nums array again, 1, 2, 3, 4 and 5. What if I already calculate the sum of each index, sum up till each index? So if I create another array and I calculate the sum up till that particular index. So if I'm on index 1, index 0 practically, so the sum would be 1. If I am on index 1, that means sum of 1 and 2, that means 3. If I am on index 2, that means sum of 1, 2 and 3. So that means 3 plus this 3, 6. If I am on index 3, that means 6 plus 4, 10. If I am on index 4, that means 10 plus 5, 15. So this is a pre-built sum of each index. Now let's say I have to calculate 0 to 3, sum of elements from 0 to 3. 0 to 3 means this element, and this element. All these 4 elements I have to calculate. That means this is my answer. That is straightforward. I would just go to index 3 and return that. If I have a query which states that calculate sum from 0 to 3, I would just go to index 3, that is 10, and minus the sum of index 1 minus 1. So left minus 1. So that is 0. So sum up to 0, I will remove from it, that is 1. Because if you see practically, if I'm saying calculate the sum from left index as 1 and right index as 3, that means this value, right? So this value means calculate the sum of all these 4 values and remove the sum of indexes lesser than the left index, anything that is lesser than. So if you remove this part from the sum, that is the answer. So that means our only aim is to calculate this and store it somewhere. So this would be ideally calculated at time of initialization of your object, and you'll always maintain this array in your class object as a private member variable. And now whenever you receive a query, let's say 0 to 3, if your first your sum would be, let's say this array is ARR, okay, so sum would be ARR of right, which is for sure. Now if your left is greater than or equal to is greater than 0, that means you have to remove something from the sum for sure. If left is 0, then you don't have to remove anything, because that means that you have to calculate the sum from 0th index to the right index, right? And the value at that particular right index is the sum of all the elements starting from 0, right? So if your left is greater than 0, that means your sum should be minus sum minus your ARR of left minus 1. So practically you will remove the sum of all elements lying before the left element. So, and this is your answer. This final thing is your answer. So this is the intuition. Now let's write an basic pseudocode. And if you are following my channel from a couple of months, so I have already solved one problem, which is how to create this array, and this is called range sum array or prefix sum array. The name can be anything, but this is nothing but prefix sum array. So if you have not watched that video, I would recommend you to click on the eye icon on the top and watch that video, how to calculate the prefix sum of any 1D array, and then you can continue watching the algorithm henceforth, because this would be very helpful. This video will be very helpful to understand how to calculate the prefix sum. I'll just give you a brief in this video, but in detail I have already created that video, so you can have a look at that video. Now let's discuss a algorithm, and then we'll go to the code and map this algorithm with the code logic. So our algorithm is very simple, straightforward, two-step process. The first step states that calculate the prefix sum while you are initializing the object and store that prefix sum array in your object somewhere. And now in your sum range function, you just find the prefix sum, use the prefix sum to find the sum using the logic that is written in green. So the logic is the sum variable is equal to prefix sum of the right index, and if your left is greater than 0, then sum would be sum minus prefix sum of left index minus 1. So one value before that. So because we have to include the left index, so anything that is before left index should be removed, right? So this is the only straight logic that will be written in your sum range function. Now let's see the code and understand the time complexity also for this example. Now I have written this code in Golang because that's a language choice for me. You can use the same logic in any language of your choice, let's say Java, .NET, JavaScript, Ruby, or any language that you prefer to use. So let's try and map the algorithm steps and calculate the time complexity and space complexity of this problem. So the first step states that initialize a prefix sum array containing the prefix sum result, and when you have that array, return the object or create the object using the prefix sum. Now in the constructor of my class, so this is the class nums array, and I have a variable that is prefix sum. I don't want to store the nums array because that's of no use for me, because any sum range that I'm calculating, I am using the prefix sum. So I will not store nums for now, just to make it a little easier. But if you want to store it, it's your choice. You can store that. Now the prefix sum I'm calculating over here. So prefix, this is calculating the prefix sum. So if you see, this logic is running from 0 to n. N is the length of your nums array, and your space that I have created, a new space, is also containing n integer elements in that array. So that means for this particular logic, my time complexity is big O of n, and space complexity is again, big O of n, because I'm utilizing extra space as well for calculating the prefix sum. Now I have initialized the object from the constructor, and in that initialization I have added the prefix sum value that we just, prefix sum array that we just calculated. Now let's go to the sum range part. Now in the sum range part, it's very straight and simple. We are just calculating if left is greater than 0, then we have a left value, and then our answer would be right value minus left value. And if the left value is left index is equal to 0, let's say, so left value would be 0 and our answer would be only the right index, the prefix sum of right index. So this is having a time complexity of big O of 1 and space complexity of big O of 1. This particular logic. That means my total time complexity for this logic comes up to big O of n plus 1, which is equivalent to big O of n, and my total space complexity is resulting big O of n plus 1. Now why plus 1? And plus 1 I'm only specifying for one range query. For each range query, this is my space complexity. So that is equivalent to big O of n. So my final solution has just come up to big O of n. And for each, only if you have to calculate only for the sum range function, the time complexity and space complexity is big O of 1. But if you want to calculate the overall time complexity and space complexity, I would say that the time complexity is big O of n and big O of n for space complexity. So hope you like the solution and the explanation. Please do not forget to like, share and subscribe to our YouTube channel. Also comment down below in case you want us to solve any particular problem from LeetCode or any other place that you wish to solve from, and we would happy to help you guys.